I need a deep breath. Okay. All right. So there are three different chi-square tests. The one we already learned was the goodness of fit. That one, we put the things into L1 and L2 in the calculator. I very specifically said this one is not a list. So here's what you need to know. Multiple random samples and a table. Multiple random samples and a table. Also, you can kind of tell which one this is by how it's listed in the question. So you want to say there is no difference Okay, and then what you're going to do is you're going to end up copying off the problem. But the most important thing is that the null hypothesis is no difference. Nothing interesting going on. Nothing weird here. No difference. And the only thing that changes instead of no difference is there is a difference. And you'll be able to see, we're going to do an example with the cut and paste. I think you probably already found it, where we'll be able to copy off the problem and you'll be able to see. Okay, this is called a chi-square test of homogeneity. What does the word homogeneity mean? Yeah, same across things. So basically think of this as a chi-square test of sameness. How same is it? How different is it? Same, different. Okay, now this one is irritating because you have to check all the samples for the conditions. So there's my irritated emoji. There's my even more irritated emoji. Okay, now we don't do expected counts the same way. It's very specific for a two-way table. There's a formula. This might not make any sense to you until we actually do one. So if for the rest of this, to be honest with you, through the do, some of this stuff isn't going to make sense. And that's because we actually have to get a calculator out and really do it for us to understand. But we're going to write down what we're going to do for now, and then go to the calculator and practice it. It'll make way more sense then. Okay. Now for the do step, you can do it by hand. Okay, this is how you do it by hand. You take all of the observed minus expected squared over expected, calculate the chi-square statistic, and then use chi-square CDF to find the p-value. I don't know if I'm ever actually going to do that, to be honest with you. I don't even think I'm going to do it in the example. Because the calculator will do it for you. But you have to use calculator functions that you've never used before. Ooh. Okay, now I'm too far down on the page. I copied and pasted or cut out and pasted my problem at the top of the next page. So it's up to you if you want to put it at the bottom. You can. If you want to put it at the top of the next page, you can. Either way, I'm going to sit here and drink my Diet Coke. Mm, that's a lie. I'm going to come stand Lydia and Christina. That's what I'm going to be. I'm going to be responsible. Is anybody still writing? No, it's cool though. I was watching it. It's super cool. Boop. But there's no eraser. Okay, but you can have a separate one. It's no big deal. It's really cool. Grace hates everything I love. I'm kidding. I joke. I joke. Grace, please don't put the little. Grace, I brought Mr. Hanks today. He's got suction cup fridge on the bottom. Okay, Grace hates everything I like. I'm just kidding. I love her. Vegas Mad is it's this like old white guy that plays a lot of slot machines every single day. It's kind of like a train wreck that you can't not watch because he just pours thousands and thousands of dollars in the machine. And it's like you would never do that yourself. Like you just couldn't. So like it's fun to watch somebody else just like piss their money away. Anyway. Sometimes he wins, which is a really good date, but then he gets mad when he doesn't win. And I'm just like, but you do this every day. On the next test, the first problem was about roulette. So I did it for Seska and Damien. They must not have read my note. They didn't read it? Oh. I actually did. Okay. The other day, he was like, I'm starting to feel he didn't say that. I'm putting words in his mouth. But like, I'm starting to worry about the fact that you taught us 3.2 million different types of intervals and hypothesis tests in the last semester. And then when I go to take the AP exam, how do I tell them apart? That is a valid concern. That's not what you said. I sort of exactly. Okay, but for now, we don't need to worry about that quite yet. But for now, for the chapter 12A test, did you guys all notice I split it into two tests? It's actually technically. You need to tell apart the three different chi-square ones. So let's just focus on that for now. First thing you can tell, this one has a two-way table, not a list. Can you guys tell the difference between a two-way table and a list? So a list is like one-dimensional, and a two-way table is like two-dimensional. Okay? Which means I have to use multiple lists to type this in. Okay, got it? Okay. This one has a two-way table. And it says in the problem, researchers compared random samples. Samples up. Multiple random samples. Okay, which means that they got a very separate sample from Canada and a separate sample from US. They weren't like hanging around the border trying to figure out like who has dual citizenship or anything like that. The Venn diagram does not overlap in these two samples. A sample from the US, sample from Canada. Okay, so I'm thinking to myself, first, does it have a list or a two-way table? So you're like, this is your mind. If I have a list or a two-way table, if I have a list, chi-squared goodness of fit. If I have a two-way table, it's either chi-squared test of homogeneity or the other one we haven't learned yet. And this one is the one with multiple random samples. The other one's just going to have one random sample. That's how you'll tell them apart. Also, the directions will be different. But anyway, okay. It says, how do the United States and Canada compare in treating heart attacks? Researchers compared random samples of US and Canadian heart attack patients who stated their own quality of life rating compared to what it had been before the attack. Here are the data. Okay. So we've got the table over here. Notice I gave you a blank spot over here. This is where we're going to calculate the expected counts. These are the observed. And if you want to, you can label that observed just to keep things straight in your mind. And then this is going to be the expected, which we're going to have to calculate. You're always given the observed and you have to find the expected. Is there a significant difference between the US and Canada's quality of life ratings? Carry out a test at alpha equals 0.01. State. Ho. There is no significant difference between the US, Canada. What country is Canada? Would they have candy there? Mhm. I feel like it's just kind of necessary to add that in because they're not talking about quality of life ratings just in general, very specifically after heart attack. Oh my gosh, I did it again. I must have a mental block writing the word Canada. Going to wash your hands. Okay. Okay, so I said no significant difference for the null hypothesis. Just copied off the problem, but I did add after heart attack because that's what this problem is about. So just want to make sure I'm being specific enough there. And then there is a significant difference. Same thing. No difference. Yes, difference. Okay, now the plan. Chi-square test. This is why you shouldn't eat fun lunch on a Friday because you're just gonna get all tired. Oh, chi-square test of homogeneity. Okay. Separate random samples. Oh, I don't want to write this part. Okay. I got it. Oh no, I don't got it. This is bad. Calculations have to be performed. Wow, is it bad that there are just way more to choose from in the US with heart attack? Is that a thing? Or is it just a bigger population? Okay. Much worse is anyway. I don't even know what to think of this data. Okay, 2165. Everybody good with the calculations I did there? Just added up the totals and then added up the totals and the totals and then got totals of the totals and total totals. Okay, what was the sample of anyway? US and Canadian horse. Okay. So the 311 is Canada. I did it. Okay, now we get to take a writing break. And I have to teach you all the calculator things. Okay, so get here and then stop and make sure you have a calculator. And you cannot get lazy on this one. You have to operate your own calculator. Fine. I'm pretty I'm pretty sure that no one in here has done this calculator function before, ever. Not even calculators does matrices anymore. So, I mean, unless you're just one of those people who's really curious and played with the calculator, I don't think that we've ever touched the matrix function. We're going into the matrix. What? That's cool. Oh, okay. That makes sense. Okay, so we're gonna go into the matrix. Yeah. Okay, so what we want to do is put the observed into a matrix. And matrix is located right on the inverse button. The inverse button is right below the math button and it's above. So you have to hit the blue button first. Oh, actually, is yours blue? Yeah. Blue. And then the inverse button and find the matrices function. Okay, let me do it again. Hit the blue button. And then the inverse button was just the one under the math, like right below the math button. And then you should get a menu that looks like this. Now, you probably don't have anything in here because you haven't played with yours. I've played with mine. So, okay. Now scroll over to edit. And then hit enter. And I specifically have a 2x4 matrix in here. We want a 1, 2, 3, 4, 5 by 2. So change your dimensions to be 5 by 2. And then type in the matrix 75, 541. And you can just hit enter. It'll go to the next cell. Make sure to not put the totals in. That'll throw off the whole thing. So the observed, the ones that you get when you sit down and print it on the problem are always matrix A. Make yourself do it. Muscle memory is a thing. Okay, does anyone need any assistance or more time? Okay, now shift, we're gonna find the expected counts next, but I'm gonna be lazy and I'm gonna have the calculator do the math for me. Okay, go second inverse, back to here. Second inverse, back to here. Scroll over to edit again and go to B and make it 5 by 2. Okay, now you can actually type math into these cells. And I told you guys the notes back here. The formula is row total times column total over total total. Okay, this box goes with the 75 over here. I'm finding the expected count for the 75. Okay, what is the row total for this cell? 616 times. What is the column total for this cell? 311 divided by, what is the total total? And then hit enter, and then you can put that number here, 77.373. Okay. Next one. Let's do this one here. Row total. 616 times column total. 2,165 divided by total total. Okay. Now just keep going. 569 times 311 divided by 2476. That's 69 times 2165 divided by 2476. We'll not have them for the totals. Don't put any in the total spots. What would you total anyway? Did anybody get anything different from me? I'm asking because I'm sleepy and I won't worried if I typed a number wrong. Okay. All right. So now we're going to do the part where we have to show our work down in the view section. pi squared equals. Start with the very first cell, the one that's 75. Observed minus expected squared over expected plus observed minus expected. That's not right. There's a long decimal after that. And remember, for College Board's sake, you just have to show the first two and the last one. Yep. And I'm not even going to figure out what these are. The calculator's going to do it for me. I don't have to do anything. I'm just blindly writing those down to show my work. Yeah. I just counted this as the first two and the last one.
Oh, I see.
Because the calculator, when you hit enter, it goes here, here, here. No.
No.
Yeah. Okay, now we're gonna see how fast the calculator is. So go out of this, stat, tests. Okay, and I didn't show you this the other day, but if you scroll up instead of down, you can get to the chi-square. It's a lot faster. And then observed is in A, expected is in B, go down to calculate. Down to whatever. Oh, we do. You're so good. Unfortunately, I seem to have bumped my calculator and lost everything. Just a sec. Okay, hold on. No. Oh, excellent question. Hold on. Forgot all about that. Okay, back up here. Are all the expected counts great? Yeah, they are. Nope. There's none of that on the whole chi-square business. What? Oh, okay. Jordan, I think it was Jordan who asked an amazing question about degrees of freedom. So let me draw you a picture. I'm out of Post-its. Please hold. Still holding? Hold, holding, 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 holding. Okay. Let me draw you a picture of a 5x2. Okay. Um, Don't write anything, guys. Just observe. Okay, are you ready? Do you see where I got this from? Okay, Jake, give me a number. Okay, so hold on. Am I free to choose this number? Yeah, okay. Now, you guys, for some reason said 4. Am I free to choose this number? No. Okay, give me another number. Are you free to choose this number? No. Give me another number. Are you free to choose this number? No. Are you free to choose this number? No. Are you free to choose this number? No. Degrees of freedom 4. Okay, I like to call it the loser theorem. You take your hand and make an L shape like loser, and then you put it over the table, cover up the last column and the last row, and that's what your degrees of freedom is.
Oh, that's okay.
Oh, yes. Okay, here's the truth. The calculator's gonna calculate it for you, as you can tell. Yeah, the loser theorem always works. Some people like to say rows minus 1, columns minus 1, like times columns minus 1. But I just like to do the loser theorem. Anyway, so that's where degrees of freedom 4 came from. Okay, last thing. Did we do it? What was it? Point? Oh, we didn't. Oh, this makes me feel better. I'm glad that there's not a difference between the US and Canada. I mean, of their quality of life ratings after a heart attack. True, true, true. You could really just manipulate these any way you want, but that's why you're supposed to declare an alpha at the beginning. So you don't cheat, just change alpha at the end. Yeah, I don't really know if it really needs to be 0.01 in this case, because it's like a self-described quality of life rating, but whatever. Okay, last couple of minutes of class, I would like you in your groups to try to spit out the p-value interpretation without looking it up. You got this. P-value interpretation stat on the paper in your groups, please. No. All right, check mine. We're getting there.